This is a working model of Tesla's wrist mechanism. At least my version, made from junk box parts. And basically it's just two actuators, and this is the hand. And the whiteboard serves as the forearm, and the hand is mounted on a simple gimbal. And I'll just plug it in and you see the way it works. See, it's got 2 degrees of movement. It's got the pitch, and then yaw, and then any roll would be formed by turning the forearm just like a human. And I thought this was very interesting. I got excited about this mechanism by watching a video, an interview of Scott Walter by Herbert Ohm. And Scott was analyzing the Tesla robot, and he did some graphics modeling of the mechanism, the wrist mechanism. And so I just got so excited about it, I wanted to make my own. And just a couple of comments on the mechanism. The Teslabot is not using servos for actuators. It's using a couple of linear actuators, and it keeps them further up on the arm, and so that keeps the weight out of the wrist area. Because if you put these servos down and operated the wrist mechanism with servos, the hand would be very heavy. And so there's some ways you can alleviate that. You can operate it by moving the actuators up the arm, or cables, using cables. There's other robots out there with wrist mechanisms that some of them are just very, very complex. They use parallel arms and or use the actuators right in the wrists. And this seems to be one of the simplest mechanisms that I've seen. I don't know if this is entirely Tesla's creation, but it's pretty cool. Now, on mine, I used an old caster wheel and just cut the wheel off and put a couple of angle brackets in there, and it gives it 2 degrees of movement. It gives the pitch and the yaw. And one thing that I did discover is you've got to have an offset between the forearm and the wrist, or this kind of mechanism won't work. Because if there's no offset, if for instance the forearm had a ball socket joint and went straight into the wrist, you'd be able to do this kind of movement, but you wouldn't be able to do this, because it's the offset between the forearm and the wrist that allows you to do the pitch. So there's got to be some sort of offset here. Now I think you could put the ball much closer to the wrist, and I've seen that in some other ones, but they use 4 actuators, 1 for each corner. And so if you want to limit the number of actuators, which is what Scott Walter was talking about Tesla doing, they wanted to limit their number of body actuators to 40 something, 42, something like that. So this is the lowest count number of actuators for this movement. So you would have 3 for the entire arm. You'd have 1 to turn the the forearm. And the reason that they want to do it this way is they want to mimic human motion as much as possible so that they can use the same power tools, and so that their robot is doing the same movements as a worker in their factory. And so I thought that was pretty cool. And that's about it. It's about as simple as it gets. Now, I used a couple of hinges, plastic hinges here, and actually you could mount this directly onto the wrist, but I found that in here the allowed movement was so small because the head of the screw binds, and so you wouldn't get nearly as much yaw as you do with these hinges. So the hinges have a little play in them in certain positions when you like pushing the whole thing forward. You'll see a little slop there. And so this is not the best solution. It's just that it's what I had on hand to build this model. And I'm running it on an Arduino Uno. And actually this is running entirely off of the 5 volts out of the computer, which is surprising because these are standard size servos. And so I don't even have to use my power supply. I don't have to use an external power supply. I'm just running it off the Uno. And so I wrote a little routine to interpolate these servos so that you can move them exactly at the same time. And that's the only way this can work. Now there is a library out there, a servo library out there that has that built into it. And also you need to be able to control the speed, because if you use it at full speed of the servo, you're going to break something. So you need to be able to control, you need to be able to slow down the servo and also move them at the same time, so that they're both moving at the same time like this. When I started making this, I first started off using a little universal joint, but then realized once I had mounted the hand that a universal joint is 3 degrees of freedom. It has the pitch, it has the yaw, and it has the roll. And if you try to use the universal joint, the roll will just, there's nothing to support it here, the roll will just fall over. So you have to use a 2-degree freedom. So you can use this gimbal type mechanism, or you can also use a ball and socket joint. And the ball and socket joint would actually simplify this even much more.